Alright guys, welcome to this page of the notes. Now what we're going to do here on this page is talk about some special matrices. As we're working through these sections on matrices, we're going to run into some really special matrices that do a lot of incredible things with the math that we're going to be, the operations that we're sort of going to be performing on these matrices. And I just want to introduce you to a couple of them here. So when it comes to these special matrices, the first one we want to take a look at is what is known as a row matrix. Now, the reason we call it a row matrix is because it is a matrix that only contains one row, right? I don't care how many columns it has. It's a row matrix because it is one row. It could be one row, one column, one row, two columns, one row, three columns like I have. You could have one row, 100 columns. As long as it only has one row, we'll call it a row matrix. Sort of the opposite of that then would be a column matrix, where as long as you have a single column, just one column of elements, you can have as many rows as you want to. In this case, I have 3 rows. But the point here is that n, the number of columns, is always going to be 1, just like above where the number of rows was always 1. So that there's going to be our definition. 1 by n matrix, you can have as many columns as you want, or an m by n matrix, where you can have as many rows as you want, but just a single row here and a single column here. A really important one that we're actually going to look at a lot here in this course is going to be a square matrix. We actually saw one on the previous page of the notes where we looked at a 3 by 3 square matrix. We can also have a 2 by 2, 4 by 4, 5 by 5, right? As long as the number of rows and the number of columns are the same, it's going to be a square matrix. Now in this case, what we have here is n by n. You could also just as easily called it an m by m. The point here is just simply this. If I give you a matrix that is m by n, and m is equal to n, it's going to be a square matrix, right? As long as the dimensions are the same. Whatever the number of rows, it's equal to the number of columns, you have a square matrix. And we are going to come across a lot of square matrices as we work our way through this chapter. And then finally, the last one we want to talk about here is this zero matrix. Absolutely is totally possible to have zeros in your matrix. In fact, you're going to love zeros. The more zeros that your matrix has in it, actually the easier it's going to be to do a lot of the operations that we're going to perform on these matrices. So right now you're thinking, holy cow, a matrix with nothing in zeros in it, what are you supposed to do with that? Actually, zeros are going to be awesome. We like zeros. We'll be wishing more zeros. Why can't we put more zeros in our matrices? It makes the math a little easier. But there you go. You could just have a matrix with nothing but zeros in it. So here's what we're going to do. Let's get some practice with matrices. First of all, it is totally possible to have matrices that are equal to one another. And here's how it works. 2 matrices are equal if and only if they have the same dimensions and all of the elements in corresponding positions are equal to each other. So here's what I've given you. I have given you matrix A and matrix B, and I want to know, are these matrices equal? Well, you've got to do a couple of things. First, you have to determine, are the dimensions the same? Well, it looks like I have 3 rows and 2 columns, which means that this is a 3, oh, sorry, hold up, that's my highlighter, I apologize. 3 by 2 matrix. So far, so good. I have 3 rows, 2 columns, so also 3 by 2. Fantastic. Now all I have to do is make sure that the elements in corresponding positions are also equal. In this first row, first column, the first position, I have a 1. First row, first column, I have a 1. Below that is a 3. Below that is a 0. 3 is 0. First row, second column, I got a 4, then a 5, then a negative 2. I got a 4, then a 5, then a negative 2. All of the elements in the corresponding positions are equal. So yes, matrix A is equal to matrix B. That's all you got to do. Make sure that they are the same dimensions. Make sure that all of the elements are the same in the corresponding positions. First position, second position, third position, fourth, fifth, and sixth position, right? We read through a matrix like you would read a book. Okay, so we read from left to right and top to bottom. So you would always start in the top left-hand corner as the first position and work your way through the matrix like you were reading a book, from left to right and then down from top to bottom. All right, I got a couple more questions for you guys here when it comes to matrices. Actually, I want to know, what are the dimensions of this matrix? We call this one matrix C. Again, you just need to remember that to find the dimensions of a matrix, it is M by N, which is rows, then columns. So how many rows do I have? I agree, it looks like I've got 2 rows. I've got a row here, my top row, and the row here, that's the bottom row. How many columns do I have? Yeah, I agree. It looks like I've got 3 columns. 1, 2, 3. 3 columns. Awesome. I'd like you to draw a 0 matrix that is 2 by 5. And I don't tell you what to call the matrix, so you can name it whatever you want. I'm going to go ahead and call it N. Make sure you use a capital letter to name your matrix. And I need the matrix that has 2 columns in it, right? Because it's rows times columns. Rows times columns, I need 2 rows, 5 columns. Okay, well, first row, and it's a 0 matrix, so all of my elements are going to be 0. There's 1, 2, 3, 4, 5. That's my first row. First row, 5 columns. I need 2 rows and 5 columns, so 2, 0, 0, 0, 0, and 0. Put it in brackets. And there is a 0 matrix with the dimensions 2 by 5, 2 rows and 5 columns. Finally here in this last one, I ask you to write a matrix that is both a row and a column matrix. Interesting. Again, I don't tell you what to call the matrix. Let's go ahead and name it K, or you can name yours whatever you want to, but I'll name mine K. And I need to be both a row and a column. Well, let's remember those special matrices. A row matrix is a matrix that had just a single row, just 1 row. And a column matrix was a matrix that had just 1 column. So how can I have a matrix that is both a row and a column matrix? Well, it would have to be a matrix that has just a single element. Let's make that element an X. This represents both a row and a column matrix. I have 1 row, I have 1 column, I have 1 element, a row and a column matrix. Guys, we got a lot more stuff to cover with matrices. I hope you're having fun so far. I sure am. Head on over to the next page of the notes and I'll meet you guys there.